So, hi everyone, and welcome to this video of a two sample proportion test in Python. So this follows our first video, which basically goes through a one sample t-test and a two sample t-test in Python. Now we're gonna basically load up our two sample proportion test and see how that works. So just to recap, we loaded this data set, the current population survey in March 2009, which has these variables, which we'll be sort of dealing with again today. So suppose now, okay, suppose I want to look at the proportion of people who work more than 40 hours a week. Um, so it's like now we're not dealing with raw numerical or ordinal values, and rather we're dealing with proportions in this case. Okay, so let's call let's call these people overworked, right? That's more than what is typical in a week, so probably overworked. Okay, so create a variable called overwork, indicating if hours is greater than 40. Okay. So that's basically we're going to generate this sort of dummy variable here. Okay, and we're going to look at sort of this. Now we should see an overworked here. So notice this person works 45 hours. So that's indeed higher than 40. So it will be 1. This person works just 40. So it will be 0. Okay, so we have that. Okay, so now that we created this sort of proportion value, so we can compare the proportion of males who are overworked, right? Because we have the female a variable here that can denote male or female, right? Let's call this PM and compare that to the proportion of females overworked. That's P underscore F. Suppose we want to test that hypothesis, so we can test H naught, which is going to be, for example, that these proportions are equal. So what does that mean? It just basically means that the proportion of males who are overworked are exactly the same as the proportion of females that are overworked. And we can test that against the obvious alternative that they're not equal, right? So as usual, so we can do that. And now we have our null and our alternative hypothesis. But notice something here, because these are sort of differences, well, we can rewrite this, okay? This can be rewritten as very simple. So notice H naught, that can be basically P underscore M minus P underscore F equal to 0. And we also have HA being, you can rewrite it as P underscore M minus P underscore F not being equal to 0. So it's like whether the difference is statistically different or not from 0 is another way to sort of repurpose or restate the initial claim of the hypothesis, right? Now, to better sort of visualize this, we can use something called a frequency table. A frequency table is a very commonly used tool in statistics to generally see what's going on with these proportions. Okay, so let's sort of say generate a frequency table. Oops. Let's use the AI for this. Generate a frequency table of the variable overwork and female with row and column totals. So let's see how this goes. AI should work. Okay, so that should do that. So we see here that on the column, this column would be males, this column would be females. This row would be people who will work less than or equal to 40 hours. People who work more than 40 hours would be in this one. So for example, in this data set, there are 17,938 males who are not overworked, right? By contrast, you have 4,880 females who are overworked. And then here you have 16,722 females who are not overworked. Okay, now from this, okay, we can calculate, okay, the proportions, right? So we can calculate the proportions basically. and we can sort of get this out. Okay, that well, we have the proportions, and now we see that in here we find that the proportion of males that are overworked are 38%, and the proportion of females that are overworked are 22.5%, right? So that's 22.5%. So if these are the proportions of males and females, okay, that are overworked, okay, well, we can do something quite simple, which is you know, we can run, okay, a test on it, right? We can basically test out, okay, we can test, okay, whether or not that difference there, okay, is statistically significant, right? Whether that is statistically significant or not, okay? So to do that, okay, what we can do is we can run, okay, basically a two sample proportions test, right? So we can run a two sample proportion test, and that will tell us whether that difference is statistically significant or not. Okay, so run a two sample proportion test. And clearly it will definitely show, okay, that the count, okay, for sure, would be statistically different from each other, right? So we see here there is evidence, okay, there is evidence, okay, there is evidence to show that there is a statistically significant difference, okay, between the the average, the proportion rather, the proportion of males and females overweight. Okay, so that's the two sample proportion test. Quite simple, quite easy to implement. Thank you for your attention, and I'll see you in the next video where we discuss the chi-squared test. Okay, so thank you for your attention, and I'll see you in the next video.